Hello everybody, I am Nandish from Sri Venkateswara College of Engineering, Bangalore. The topic of my presentation is corrosion and its types. What we learn in this topic? Introduction to corrosion, types of corrosion. There are two types of a corrosion. Differential metal and differential aeration corrosion. Electrochemical theory of corrosion. What is corrosion? Metal and alloy are used as fabrication or construction material in engineering. If the metal or alloy structure are not properly maintained, they deteriorate slowly by the action of atmospheric gases, moisture, and other chemicals. This phenomenon of destruction of metals and alloys is known as corrosion. There are some examples for corrosion. Two types of a corrosion. Dry corrosion and another one is wet or electrochemical corrosion. Dry corrosion. Corrosion occurs in the absence of moisture. It involves direct attack of chemicals on the metal surface. The process is slow. Corrosion products are produced at the site of corrosion. The process of corrosion is uniform. Example for the dry corrosion. Formation of a AgCl on silver metal. Another type, wet or electrochemical corrosion. Corrosion occurs in the presence of conducting medium. It involves formation of electrochemical cells. It is a rapid process. Corrosions occur at anode, but rust is deposited at cathode. It depends on the size of the anodic part of metal. Example for the wet corrosion, rusting of iron. Type of fake corrosion, differential metal corrosion or galvanic corrosion. Definition of the differential metal corrosion. Galvanic corrosion occurs when two metals having different composition are electrically coupled in the presence of a electrolyte. The more reactive metal will experience severe corrosion, while the noble metal will be protected from the corrosion. Causes of the differential metal corrosion. Difference in the electropotential of the two metals in contact with one another. There is an electrical path between two metals. A fluid such as atmospheric humidity or salt fog exists that is able to break down the metals. Metal with low electrode potential act as anode. Metal with high electrode potential act as cathode. The anodic metal undergo oxidation and gets corroded, as shown in the figure. A reduction reaction occurs at the cathodic metal. The cathodic metal does not undergo corrosion. The reaction may represented at anode. Oxidized the metal gets oxidized gives rise to oxidized metal ion and electron. At cathode, water and oxygen reacts with gives rise to hydroxide. Factor affecting rate of a galvanic corrosion. Higher the potential difference between the anodic and cathodic metals, higher is the rate of corrosion. Smaller anodic area and larger cathodic area increase the rate of galvanic corrosion. Differential aeration of a corrosion. Definition of the differential aeration corrosion. Differential aeration corrosion is a type of a corrosion that occurs when oxygen concentration vary occurs a metal surface. The varying concentration of the oxygen creates anode and cathode on the metal surface. Preferably anodic portion undergoes corrosion. There are two types of a differential aeration corrosion. First one is pitting corrosion, another one is waterline corrosion. This type of a corrosion occurs when two different parts of the same metal are exposed to different oxygen concentration. Example, an iron rod partially dipped in water. The part of the metal which is exposed to less oxygen concentration acts as anode, shown in the figure. The part which is exposed to more oxygen concentration acts as cathode. The anode region undergo corrosion and cathodic region is unaffected. The reaction may represent it at anode. Oxidize the metal take place to give a metal ion and electron. At cathode, water and oxygen reacts with gives rise to hydroxide. Another type, pitting corrosion. Pitting corrosion is localized corrosion of a metal surface confined to point or small area that take place the form of cavities. Pitting corrosion is one of the most damaging form of a corrosion. Pitting corrosion is usually found on passive metal and alloys such as aluminum alloys, stainless steels, and stainless alloys when the ultra thin passive film is chemically or mechanically damaged and does not immediately repassive, the resulting pits can become wide and shallow or narrow and deep, which can rapidly perforate the wall thickness of a metal. This is a picture of the example pitting corrosion. Another one, a type of corrosion, waterline corrosion. When a iron rod is partially filled with a water for a long time, the inner portion of the iron rod below the waterline is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode, undergoes corrosion. The upper portion acts as the cathode and is unaffected. The distinct brown in line formed just below the waterline due to the deposition of a rust as shown in the figure. The reaction may represent at anode. Oxidation gets gives rise to the metal ion and electron. At cathode, water and oxygen reacts with gives rise to hydroxide. Other example, ships which remain partially immersed in seawater for a long time undergo waterline corrosion. Thank you.